I'm going to give it in 4 steps how to solve equations with the variable on both sides. So if you can get these 4 steps down and you follow them every time, you should be able to get these answers right. So your first step here is eliminate parentheses. Do you remember those problems with the parentheses? Do you guys know how to eliminate those parentheses? Usually, you use this property. I mean, yes, you do that for all of these, but a specific property.
Associative property?
Not associative property, distributive property. Remember, you have like a sum in parentheses with a number outside. You're going to use a distributive property. So eliminate the parentheses. Sometimes you usually use distributive property, but sometimes you just want to multiply. All right, second step. Once you get those parentheses out of the way, you're going to add like terms. Add like terms. And you're going to do that on both sides of the equation. So just make sure all like terms are combined on the left and on the right. Just add them all. That's your second step. Your third step is to, and this one is where you have variety. You send the variable to one side of the equation. And you can send it to either side. You can take the variable that's on the right and send it to the left, or you can send the variable on the left and send it to the right. It doesn't matter, but one usually is easier than the other. And we'll talk about that as we work some problems out. And then the last step, maybe the most complicated. Solve. Once you get the variable to one side, you're going to be able to say, all right, what's happening to the variable? It's being multiplied, then added. So you undo the addition, then divide to undo the multiplication. Bella.
What would be the fifth step?
Sorry?
Would there be a fifth step?
Check.
Yes.
Very nice. Very nice. Yes, ma'am.
What would sending the variable to the other side look like?
Well, I'll do that on the next problem. I'll actually do it 2 ways, sending it to the right or sending it to the left. We'll see what happens. Okay, good question, though. All right, let's go to page 348. So we're going to actually go turn the page. And we're going to follow these steps every time. And hopefully you guys will memorize them by the time we get done with this lesson. But I'm starting with number 4 on that page. So page 348, number 4. And this is what they give me. 12k plus 15 equals 35 plus 2k. I'm going to work this out 2 ways. But we're going to go through those 4 steps. Okay, step 1 is to do what? Eliminate the parentheses. Are there any parentheses? No. So you can already be done with parentheses elimination because there are none. Step 2, add like terms on both sides. So on that left side, are there any like terms? No. On the right? No. You're done with step 2. Step 3, get the variable to one side or the other. Okay, so this is what I mean by getting it to one side or the other. I can either subtract 12k from both sides, or I can subtract 2k from both sides. Which one do you think I should do? Sophie?
Subtract 2k from both sides.
Why would I probably, not that I can't, but why do I probably not want to subtract 12k from both sides? Why is that not that great, although it's possible and workable? Jensen? Yeah, you're going to deal with a negative now. Might as well deal with positive. So I'm going to subtract 2k from both sides. So really what you did was you took the variable on the right and you sent it to the left. Do you guys see what I mean by that? Is there any more variables on the right? Are there any more variables on the right? No. Nope. But then you add like terms here and you get 10k plus 15 equals 35. I got rid of that 2k. All right. So we set the variable on one side or the other. 4th step is to solve. And I hope you guys know how to do this. So what's your first step?
You subtract 15.
Good. Subtract 15 from both sides. These will cancel out. I'm left with 10k equals 20. Last step here. Yes, ma'am, Callie?
Divide 10 on each side.
divide by 10 on each side. I get k equals 2. And bonus step or extra step or make sure step is to check it. So I check it with the original equation. We can do this mentally. Okay, so this is mental math. What's 12 times 2? 24 plus 15. So I'm going to put 39 over here. What's 2 times 2? 4 plus 35. Does it check? Yes, so this is the answer. It has to be the answer, right? 2 is the only one that works. You guys get that? All right, I want you to work number 5 on your own. Do you have to do step 1?
Yeah.
On number 5?
No.
It's done. Step 2?
No.
Oh, step 3?
Yes.
Get that variable to one side or the other, your choice, and then solve it. Check it if you have time. If you get done early, you need to check it on your own so that you can confirm, yes, that's the answer, or no, that wasn't it. Okay, as you guys are working, did most of you subtract 3x on both sides?
Yes.
Okay, I'm going to subtract 4x on both sides. Did you guys get that?
I didn't finish.
Oh. Did you get x equals 3 even though you didn't follow my process?
Yes.
Okay, if you didn't follow my process, you probably subtracted 3x from both sides. That gives you 2 equals 1x minus 1. You add 1 to both sides, you get 3 equals x, or 3 equals 1x, which comes out to 3. Yes, ma'am?
Why would you subtract 4x?
Because I felt like it, kind of. But I want to show you that either way, listen carefully, guys, this is a good question because you can choose. Some of you might think this is harder, some of you might like it. I don't know. But here were my options. Look at the beginning problem. You could have subtracted 3x from both sides. Doesn't it eliminate from the left if you do that? Or you can subtract 4x from both sides first. Doesn't that eliminate it from the right? So either way, you got the variable to one side or the other, and then you work it out like normal. But both of us should get x equals 3. We must get that same answer if we follow the algebraic steps. So is there only one way to do these problems?
No.
Absolutely not. I'm sorry. There's not. There's many ways. There's more than that, too. Okay. How many of you got x equals 3? Raise your hand clearly so I know who got it. And if you did, it's okay. But I just want to see who got it. If you did not get it, because that's about 5, 6 of you, do you have a question? Did something happen? Can you help me out here? Yes, ma'am.
Can you do it the other way so I can see what it would be like?
I guess so. Okay, so I'm going to subtract 3x from both sides. And I get 2 equals 1x, or just x, minus 1. Then what's happened to x is being multiplied by 1, multiplied by 1, then subtracted with 1. Add 1 to both sides. 3 equals 1x, which means 3 equals x.
What I did was I added 1 to both ones. That's why I did my
Good. And this is something that's important. So that is not uncommon, and this is what's maybe getting some of us. If you add 1 to one side, you have to add 1 to the other. You guys understand that? But when I say side, you're looking at this both sides of this equal sign. So I add 1 here, and I add 1 here. Not add 1 here and here, because what did I actually do? If I added 1 here and then 1 right here, I added 2 to one side, nothing to the other, unbalanced. You just made it like this and made it kind of heavy on one side. So you don't want to do that. Good question. Anyone else? Okay, because I'm going to test you out later. All right, look at number 7. We'll all do this one. Number 7. Here's where we get a little bit more complicated. 3 times the quantity A plus 22 equals 12A plus 30. All right, step 1. Eliminate parentheses. Do we have to do that?
Yes.
Yes. How do we do that? Yeah, here you must do distributive property before you try to solve because there's an A here and A there, and you can't just start dividing or multiplying right away. So we're going to do 3 times A. 3 times 22. Do you see the signs? Positive 3A, positive 66 equals 12A plus 30. Okay, step 1 is complete. We're done with the parentheses. Step 2, are there any like terms on either side? Like terms here? Like terms here? Nope, step 2 is done. Step 3, what do you want to do? Jack?
Subtract 3.
Yeah, subtract 3A from both sides. Keep it easy for us. From both sides we did that. Notice the equal sign. You subtracted 3A from here and from here. Okay, that cancels that out. Excuse me? Okay, I'll slow it down here. Do you guys see how I subtracted 3A from both sides of the equal sign? Yes, ma'am? Okay, that's all right. All right, did we get the variable to one side? Okay, so we're now at step 4. Step 4. What do we do? Solve? So how do you solve this one? Yes, ma'am?
You subtract 30 from both sides.
30 from here and 30 from here.
And then divide both sides by 9.
And then you're going to get A by itself by dividing both sides by 9. And you get A equals 4. Or so I hope. Right? Man, that looks good. Yeah, or 4 equals 8. Good. What's 4 plus 22?
26.
26 times 3?
48. I'm 78.
60.
Okay, we said 3 times 26. Here's how I use the distributive property mentally. What's 3 times 20? 60. What's 3 times 6?
18 plus
What's 16? 60 plus 18.
78.
So I got 78 right here. Okay, 12 times 4. 48 plus 30. Does it check? Yeah, and if you need to work it out, you can. That's fine. Is Mr. A that good at mental math?
Yes. You're a math wizard.
No, I am not. I have to really think about it, and I have to practice. Just like anything, you get better with practice. I'm not good at mental math. Trust me. When someone asks me a question like, pause, get the paper out, write, wait, do I want a pen or a pencil? Do I have an eraser? Yes. 0.7 lead, 0.5 is good sometimes. Wait, what am I doing again? That's how it's going in my head. Yes, ma'am.
Okay, when you subtract 3A from each side, instead of doing that, could you subtract 30?
Okay, you could, because you're subtracting 30 from both sides. But eventually you're going to have to get the variable to one side or the other. So you eventually have to subtract 3A from both sides or subtract 12A from both sides.
How do you decide which one to do first?
Always get the variable to one side or the other first. Like that's after you've done the eliminate parentheses and add like terms, get the variable to one side. And then you can add or subtract 30 from both sides. Although you don't have to. You really could do either one first. Probably shouldn't say that out loud. Yes, ma'am.
So when you like subtract 3A, but you're adding 3A plus 66, so wouldn't that make like 66 a negative or something? Or
Right here?
add it? Yeah.
So if you subtract 3A, you're going to have to do 3A plus negative 3A is 0A. But that doesn't affect the sign of 66. It's still positive 66. So it doesn't change that, thankfully, because we're adding everything. Okay. Any other questions? Okay. Yes, ma'am.
Sophie's bleeding.
No, I am not.
Are you shedding red?
If you need to if I have a Band-Aid, I'll get it for you. Okay, how about this? Go to example 3. Example 3, so turn back, or actually it's right above there. example 3 on page 348. Write that problem for A up there. And go ahead and solve it. So example 3A. You guys start it off. And don't say anything. Just try to solve it. Try to get an answer as best you can. Then we will talk about it. Okay, so I'm thinking no parentheses, no like terms, so how do you get the variable to one side or the other? Yep, Jack?
Subtract by 2x.
Okay, I'm going to subtract 2x from both sides. And that cancels. I get 5 equals... Wait, that cancels. -3. What happened to my variable? Went away.
It's no solution, right?
Why?
Because there's no variable.
Okay, close.
Because nothing can go in for that variable.
And the reason you know that, is this a true statement? Is this a true equation? It's false, which means there is no solution. No solution. Nothing fits for x.
At least it didn't take that long. That other one I was
So how many of you, listen carefully, if you how many of you decide to subtract 2x from both sides? Okay, you guys saw that cancels out, and unfortunately that cancels out too. You're left with positive 5 equals -3, right? So is there anything else to do? Like, can you solve for a variable? Well, no, there's no variable there. So you look at this equation. If it's a true equation, we'll talk about that in the next example. If it's a false equation, no solution. By the way, check it out. Pick any number you want.
7.
Put it in there and see if it works. Whatever your number was, put it in there. See if it works.
I had 8. Mine works, it works.
All right, I'm going to pick 4. 2 times 4?
8.
8 plus 5?
13.
I get 13. 2 times 4? 8 minus 5? Minus 3 equals 5. Sorry, got ahead of myself. Is that going to be true? Nope. Do any of your numbers fit? No, there is no number that fits. That's why I put no solution. Nothing fits. Try it. Yes, ma'am.
So why would you?
Sorry, I hear talking still, and I want to make sure I hear the question. Yes, ma'am.
So why would you subtract 2x when you're making the 3 negative already? So wouldn't you add 2x if you make the 3 negative?
So if I add 2x, let's say I added, what's 2x plus 2x? 4x, and then 2x plus 2x? 4x. So it doesn't eliminate anything. So you want to make sure you eliminate at least on one side. In this case, eliminated for both sides, which is weird. Okay, but no solution. You guys get it? Or you can write the words no solution. So this is also an answer. Now, if you just put false, that is not correct. It's no solution or no solution. So make sure you remember that.
If we circle the 0 with the line here, answer.
Yep, that's the answer. But you got to show me the work that shows that answer. All right. Let's go ahead and work this one out here. And it's this B on example 3. Okay, step 1, eliminate parentheses. Can we do that? Yes, so we're going to use the distributive property. What's 3 times x? 3x. What's 3 times 1? Yep, positive 3. And then you still have this minus 5, which equals 3x minus 2. Can we do step 2? Are there any like terms to add?
No. Oh, yes. Well,
What can you
subtract,
combine?
not add. Well, necessarily.
There you go. You can say it either way. Yes, ma'am? Is there anything to combine to make it simpler?
3x and 3x.
Before you do that, there's one little thing I could do to make that a little bit easier.
You could do 3 minus 5.
Yeah, you're combining those two. Those are like terms, 3 and negative 5. 3x minus 2 equals 3x minus 2. Okay.
It's equal.
What are you going to do to solve? So you got the variable on one side, or excuse me, You got the like term, so now get the variable to one side or the other, which means you do what? What do you do to... Okay, you can get the variable to one side or the other. So you see how it's on both sides? Get it to one side. Subtract 3x. Cancel. Negative 2 equals... Cancel. Negative 2. True or false?
It's true.
True, which means your solution is all numbers.
What?
Whoa.
Every single number will work.
Every number.
Negative 3 and 53. Let's try.
You do that. Give me a single digit number, just
4.
4.
10.
All right, what's 4 plus 1? 5 times 3.
15.
15 minus 5? 10. 3 times 4? 12 minus 2? Works.
Do 5.
13? Okay,
Wait, is there another?
I got a number here. Let's check it. 13. 13 plus 1?
14.
14 times 3?
I don't know.
42 minus 5?
I don't know.
7, I think.
37.
3 times 14?
42.
41.
Oh, 14 or 13? I think it was 13. Yeah, 3 times 13. 39 minus 2?
30.
It works.
142.
You do it.
Is
It works.
there a sign for this? Like.
No. Just this.
Do negative 5. Mr. A. Do negative 5.
Hold on, I don't see hands up, so I can't answer. Okay, listen carefully. On this equation, every number will work, and I hope you can see it. You may not see it from this step, but you could hopefully see it from here. 3x minus 2 equals 3x minus 2. Isn't any number you put in for here the same as here? And wouldn't they just always be the same thing? So that would be your solution, all numbers. Okay, raise your hand. Marissa.
When you say all numbers, is that negative and positive?
Negative, positive, fractions, decimals, any number. Every number, any number. Which is really cool. Yes, Caroline?
So why would you just subtract 3x or whatever the number the variable is? The x is being multiplied, so why would you divide it?
Oh, that's once the variable, I think you're thinking, once the variable is on one side or the other, then you would start thinking about dividing it by 3. But the first step is to get this x to be either here on the left or on the right, not both. Then you start solving. Every negative number, every positive number, every fraction, every decimal, everything. A decimal would work. If you want to test it. Pi would work. It has to work. Because think of it here. If 3 times pi is some number, and 3 times pi is that same number, well, you take that number minus 2 and that number minus 2, what are you going to get? The same exact thing.
So the only reason it could be different is if they're two different numbers, which are.
Technically, yeah. And yeah, this one fits all numbers. Yes, sir.
What about
Irrational numbers? Yeah, pi is irrational. And pi works. Which is cool. Number 9 is your final problem. If you can do number 9, you're good with this lesson, I hope.
Yes.
Does that mean no homework?
No. I hear a lot of talking from this area over here, so hopefully I don't have to remind you again. And don't be too quick to give me an answer. Check it and then see if it works. Because if it works, you're good. But if it doesn't work, you got to go back to the problem. If there's a variable by itself, what number is it being multiplied automatically? 1. So you're like, wait, what? This could be a 1n and that could be a negative 1n. You have an answer?
Yes.
Did it check?
Yes.
Okay, hold it. So go through your steps. Eliminate parentheses, check. Add like terms on both sides, check. Get the variable to one side or the other. Let's see how you do with that. You have options. You could do it one of two ways, but there's an easier way. All right, John, what did you do first?
Okay, I did minus n on both ends.
Okay, so you subtracted n from both sides. I'm going to subtract n from both sides. That's allowed. You may have added n to both sides. It's fine. These will cancel out, and you're left with 4 equals negative 2n plus 10. That's if you subtracted n from both sides. That's allowed. Okay, Jermaine?
What about if you subtract 4 from both sides? Yeah. That's what I did.
Okay, listen carefully. I know what you guys are doing, but let me get everyone's attention. You could do that, but you still have to get this n to one side or the other. Okay, so you could have done that. But anyway, looking at this right here, what do I have to do first to solve for n?
Divide it by
Subtract 10.
You got to get rid of this.
And you get negative 6.
And what you divide negative 2n by both sides.
You divide both sides by negative 2, you get 3 equals n. You could have done it a different way, you get the answer. It's fine. Should be positive. Yes?
I added n to both sides backwards.
Yep, because n, you added n to both sides, canceled it here. You got 2n plus 4 equals 10. Subtracted 4 from both sides. 2n equals 6. Divide both sides by 2, you get n equals 3.
Negative 3.
Right? No, positive 3. This first part she did? If you add n to both sides, what's 1n plus 1n? 2n. That's how I got that 2n.
You only have to cancel out on one side?
One side.
So one is canceled out, the other doesn't.
Unless it's one of those true or false ones where they both get canceled. But normally they don't do that. Caroline.
So if you subtracted 4 on both sides, would that work?
Yes. But what are you going to eventually, you're going to get this. 1n equals negative 1n plus 6. But then don't you have to add the n to both sides? Did you add 1n to both sides?
Yeah.
Okay, so you have to do that anyway. You're just doing the other step first, which is okay.
Then you get 2n plus 2n plus 6. Or negative 2. I don't know.
See, and that's why if you just do it, if you always try to get rid of that variable on one side or the other, you don't have to deal with that. Okay. Your homework tonight is 11 through 25 odd.
I thought it was going to be 11 through 25.
Oh.
I said 24. I don't.
No, if you say odd, you've got to end on.
I know.
And then 39 to 44, all of those.
He always does the mixed review. Y'all know this one. I know. He always does like the random problems and then the regular problems.
Ah.
Mr. Ed,
He's trying to keep us.
this is like odd, like your thing, or do you just like never, because like you never do just like 12 to 24 each?
Yeah, you can check them. So, like, you know what you're doing.
So, like, you shouldn't get a 0 on homework.
No, you should not. All right.